Now we're going to discuss problem 11.3.6, and I put here modified because what we did earlier just had to do with these conditions shown in this problem. So we have a 200 hectare watershed in an open space and fair condition. So we are going to use the SES method or curve number or soil conservation. So we need this information, open space and fair conditions. So we have here open space, which is parks, cemeteries, etc. And then fair condition. So I know that it will be, depending on the soil, fair condition, then it's going to be here. Now, what we have then is 40% are B soils, so then we have here B soils and D soils. Okay, so then we have 200 hectares, and then we have 40%, and of course it's open space, so this is important, open space and fair condition. 40% are B soils and 60% are D soils. So important is that we can do this in two ways. We can say, okay, so we have here 200 hectares and 40% of that is B soils. So this is 80, and then 60% are D soils. So this is 100, well, 200 times 0.6. So we have 100. So then the curve number, the average curve number, would be the summation of area times the curve number for the area divided by the summation of the area. So we have 80 times 69 plus 120 times 84 divided by 200. And this should be, I think we had done 80 this morning, but it should be 78, the exact number. Okay? So now we're using the SES method, so we need to calculate the soil moisture storage deficit, and also the runoff, which is what the question is asking for. Now, these are the two equations that we mentioned earlier in the course. So first you have to calculate this, and then with the storage, you calculate the runoff. Or you can use this figure. So those figures are the same information, just in a format that's different and maybe easier, but in the exam you should use the equations. So the other thing to remember is that this, as I mentioned, these are in inches, okay? Especially this expression here is in inches. For millimeters, which is the information we have in this case, is, this is the equation, which is 11.7. I mean, you can always convert this information to inches and then use the other equation. Okay, so let's go ahead and do those calculations for S. S equals 400, and this was a 100 millimeter rainstorm, and we might have mixed up some problems earlier. So 250 or 78, remember this is the curved number, and this divided by 78, this equals 71.6 millimeters. The R then with that storage is the P, which is 100. So remember, P is given. That's the depth of the storm, the precipitation, minus 0.2 times 71.6. All this squared divided by the precipitation, again 100 plus 0.8, 71.6. So this is 46.7 millimeters. This is the runoff. The next problem, I'm going to simplify the discussion from before. We have example 1.6, and it says plot the unit hydrograph using a spreadsheet. I don't want to give you the table I gave you earlier because the table has more information than you need. So once you have the unit hydrograph, you can plot this or use the table in a spreadsheet format. You have done that before to determine the volume of runoff. So what you need to remember is this. First of all, this is a unit hydrograph. So whenever you calculate the area under this curve, the area under the curve is the volume of runoff. And whenever I have the volume would be the depth times the area. Okay? So whenever I calculate the volume and I divide by the area for the unit hydrograph, and here I'm talking about the British or US customary units, then it has to be 1 inch. Okay? So what is important here is that we are doing this through numerical integration. So you multiply each flow by the time interval associated with it. So you can do, you have here, here. So what happens is, and what I was trying to explain this morning is that you don't always have the same time interval. So if you have different time intervals, then your delta t, so it would be something like this. So it'd be the summation of qi times the time interval. Okay? So this would be the volume. And this is the concept I wanted to bring for this problem. So basically just to do those calculations. I will provide you with another example that has the table. I just felt like that other table had too much information, more than you needed. So I will leave it there. I hope these discussions have helped.